Hi, everybody. Welcome to Self Check 2.4 exercises where we were discussing the chain rule. So we want to use the chain rule to find the derivative of these functions, right? So it says dy over dx, but that really just means y prime. It all means the same thing. But let's go ahead and find that. So for this part A, we have y equals 8x cubed plus 3x squared plus 2x plus 5 to the third power, right? So if we didn't have the chain rule, we would have to multiply this all out, you know, multiply it out by itself three times and then simplify it and then take a derivative, right? But we have the chain rule, so it's a lot less complicated. So remember the chain rule looks something like this, right? Chain rule is, the derivative of the outside, inside stays the same, times the derivative of the inside. So that means for this question, right, it becomes derivative of the outside. That means this 3 drops down like a power rule, and we subtract 1 from it. So this becomes 3 times, and the inside stays the same, 8x cubed plus 3x squared plus 2x plus 5 squared, right? 3 drops down, subtract 1. That's the derivative of the outside times the derivative of the inside. So times the derivative of this guy here. So this would be 24x squared plus 6x plus 2. And that's basically taking the derivative. Now it's a matter if you want to simplify it or not. You can distribute in this 3 to this guy, right, at the end to clean it up a bit. So you can have, 8x cubed plus 3x squared plus 2x plus 5 squared times 72x squared plus 18x plus 6. That's 3 going in there if you need a visualization. But that is the derivative, okay? And once again, if you just had this, that's okay too. That'd be a correct answer, right? If you don't want to simplify too much, then you don't have to. But let's check out part B. You know what? Let's go ahead and C, and then we'll do part B last. So C is, this looks a little ugly, right? But remember, what we can do is rewrite a root into a power with a fraction. So what you can rewrite this into is actually 4x squared plus 2x minus 1 to the 5/6 because of this and this, right? We did this a little earlier before, but recall that if you have like x to the a with a b root, it's just x to the a over b. Okay, so let's go ahead and take a derivative of this, but we got to use a chain rule because otherwise we would need to multiply this out by the 5/6 or take the fifth sixth root, and that's just not possible for the amount of time that we have. So using the chain rule, right? Using the chain rule, right? Let me go ahead and copy this. Right, chain rule. So derivative of the outside is 5/6 drops down and we subtract 1 from it. So this becomes 5/6 times 4x squared plus 2x minus 1. The inside stays the same. And then 5/6 minus 1 is going to be negative 1/6. Okay. And then it's times the derivative of the inside. So this guy, which is just 8x plus 2. And then I don't want to simplify it anymore. So this is a correct answer. We could distribute in 5, 6 in there and then work some stuff out, but it would just be unnecessary. So this is a correct answer if you want to leave it like this. All right, let's look at part B now. So part B is incorporating the product rule. Right, there's a chain rule, but incorporating the product rule with the chain rule. So product rule recall is F prime plus G prime times, sorry, plus G times F prime, right? So why we're using the product rule? Well, because we have two things multiplying each other. We have x to the fourth, we have 5x plus 2 to the 1/5, and we want to find the derivative of this, but we really have no way to do that without the product rule. So we need to use that. And within that product rule, we're going to have a chain rule because of this guy. So let's go ahead and piece that out with the product rule. So we have our F, we have our G. F is usually your first one, G is your second one. So we'll have F equals x to the fourth, F prime equals 4x cubed, right? Power rule. G is 5x plus 2 to the 1/5. And I want to take a derivative of that, so I got to use a chain rule. So, that guy drops down, we subtract 1. So 1/5 times 5x plus 2, 1/5 minus 1 is negative 4/5. But then I got to take a derivative of the inside. So luckily, that's just 5. And this works out kind of nicely because 1/5 times 5 is just going to be 1. So this ends up being G prime equals just 5x plus 2 to the negative 4/5. Okay, so let's go ahead and put all this back into our product rule. So we have y prime equal f, which is x to the fourth times g prime, which is, I'll put brackets around that, 5x plus 2 to the negative 4/5, oops, plus, I'm gonna move this down a little bit, plus g, which is 5x plus 2 to the 1/5 times f prime. So 4x cubed. And once again, we really can't simplify it after this because we have these weird fraction powers here. So this would be a good answer to stop at. So that's it for section 2.4 exercises using the chain rule and chain rule within a product rule and dealing with roots. So hope that helped, and I'll see you next time. Thank you.